Namaskar. Today we will study the mechanism of action of isoniazid. So this is the structure of isoniazid, which is isonicotinic acid hydrazide, isonicotinic acid hydrazide or INH, and commonly it is called as isoniazid. Isoniazid is a first-line anti-tubercular drug. It is used in tuberculosis, and today we will discuss the mechanism of action of isoniazid, which is it acts on cell wall of mycobacterium tuberculosis. It inhibits the cell wall synthesis, and in particular it inhibits the mycolic acid synthesis. And during the mycolic acid synthesis there is involvement of two group of enzymes called fatty acid synthase, FAS1 and FAS2, and isoniazid inhibits this FAS2. FAS, mycolic acid, is a fatty acid, so fatty acid synthase group of enzymes. These are a group of enzymes. So FAS1 is there and FAS2 is there, and isoniazid inhibits FAS2. And how it occurs, let us discuss the structure of the mycobacterium cell wall. So if you see, this is a mycobacterial cell where the cell wall consists of mycolic acid, arabinogalactan and mucopeptide or peptidoglycan, and we call it as MAGP complex. The mycobacterial cell wall is MAGP complex, where M stands for mycolic acid, AG stands for arabinogalactan and P stands for peptidoglycan. Now the isoniazid inhibits mycolic acid synthesis so that the cell wall synthesis is inhibited. And inside the cell wall there is plasma membrane, and in the cytoplasm there are ribosomes and nucleic acid. How this mycobacterial cell wall or MAGP complex is synthesized? First, the fatty acid synthase 1 group of enzymes, or the fatty acid synthase 1 enzyme system of mycobacterium, are converted to are used to produce saturated fatty acid chains of 16 and 24 carbon atoms. Then in presence of fatty acid synthase 2 enzyme system, there will be production of mycolic acid chains up to 56 carbon atoms. So in this way mycolic acid is synthesized, and isoniazid inhibits this FAS2 enzymes. Now mycolic acid in presence of arabinogalactan or in combination with arabinogalactan will form a glycolipid. That means the mycolic acids are esterified with arabinogalactan, and we get glycolipid. Arabinogalactan is produced from beta-D-arabinofuranosyl 1 monophosphoryl decaprenyl in presence of arabinosyl transferase. Now this glycolipid with peptidoglycan or mucopeptide forms a peptidoglycan glycolipid complex or mycolic acid arabinogalactan peptidoglycan complex, which is nothing but the mycobacterial cell wall. So isoniazid, by inhibiting FAS2 enzymes, inhibit mycolic acid synthesis and hence inhibits the mycobacterial cell wall synthesis. Now these FAS2 enzymes, there are two FAS2 enzymes. One is anoyl acyl carrier protein reductase, ACP reductase, and second is beta ketoacyl ACP synthase. So this ACP reductase is expressed by the gene INHA, and beta ketoacyl ACP synthase is expressed by the gene Cas-A. So these two are the FAS2 enzymes which are inhibited by isoniazid. And how isoniazid inhibits this? Isoniazid is actually a prodrug. Isoniazid is a prodrug. It is metabolized to its active form. Then that active form inhibits FAS2 enzymes. So first, isonicotinonic acid hydrazide or isoniazid is oxidized in presence of manganese and mycobacterial catalase or peroxidase to isonicotinic acyl radical, or we can say this anion is formed, and this anion with nicotinamide adenine dinucleotide NADH forms the adduct, isoniazid NADH adduct, and this adduct is the active drug. This is the active form of isoniazid, and this isoniazid NADH adduct inhibits FAS2 enzyme system, which involves two enzymes. One is anoyl acyl carrier protein reductase or ACP reductase, and the other is beta ketoacyl ACP synthase. So it inhibits all the three forms of mycolic acid: methoxy, keto, and alpha mycolic acid. Thereby, by inhibiting this mycolic acid synthesis, it inhibits the mycobacterial cell wall synthesis. So this is all about the mechanism of action of isoniazid. Thank you.